Right, here we are for day 13, Advent of Code. They're starting to get a bit harder. They're certainly slowing me down quite a bit. I wouldn't say I'm particularly good at these, so if you're looking for a great and fast solution, this is probably not it. Just more challenging myself, I guess. Seeing what fundamentals I know well, and seeing if there's unique solutions for certain things. And every once in a while I'll come across something I haven't seen before. A unique way to solve a solution. Or something that jogs my memory, like I think it was like day 10 or day 9 where I had to stop that one. I didn't want to spend too long on it. I think I gave up around 2 hours and then came back and solved it the next day when I gave up on the factorization stuff, and I remembered about memoization. Yeah, stuff like that. Or I, learned something completely new. A lot of this stuff is, not what I do day to day when it comes programming. Usually it's more, just calling APIs and making, CRUD apps. CRUD being create, read, update, delete, your kind of standard generic app that most developers have probably come across. But it's nice. It's nice to jump into stuff like this. It's fun, I suppose. All right, so let's see what day 13 is going to bring us. All right. Day 13. Your ferry made it safely to a nearby port, but it won't get much further. Shuttle bus service is available to bring you. Each bus has an ID number that also indicates how often the bus leaves for the airport. Bus schedules are defined based on a timestamp that measures the number of minutes since some fixed reference point in the past. At timestamp 0, every bus simultaneously departed from the seaport. After that, each bus travels to the airport, then various other locations, and finally reaches to the seaport to repeat its journey forever. Bus schedules are defined on a timestamp. How often the bus leaves the airport. Okay, your note, your puzzle input consists of 2 lines. Wait, what does this say? The time this loop takes a particular bus is also its ID number. The bus with ID 5 departs from the seaport at timestamp 0, 5, 10, 15, so on. Okay. If you are there when the bus departs, you can ride the bus to the airport. Your notes, your puzzle input consists of 2 lines. First line is your estimate of the earliest timestamp you could depart on a bus. The second line lists the bus IDs. You can save time once you arrive. Your goal is to figure out the earliest bus you can take to the airport. There will be exactly 1 such bus. For example, suppose you have the following notes: 939, and then this. Because the first line is your estimate of the earliest timestamp you could depart. Okay. So 939. The bus IDs in your service are 7, 13, 59, 31, and 19. Near timestamp 931, these bus IDs depart at the times marked D. The earliest bus you could take is ID 59. Okay, makes sense. It doesn't depart until timestamp 9:44, so you need to wait 5 minutes before it departs. Multiplying the bus ID by the number of minutes you need to wait gives you 295. Okay, what does my puzzle input look like? Come on. Uh-oh. Okay. What are these X's? Your notes consist of 2 lines. First line is your second line lists the bus IDs that are in service. Entries that show X must be out of service. Okay. So let's get our test stuff. So our departure is going to be, well, earliest departure. It's going to be our first line. And then we need a list of buses. And, oh, what am I doing here? Lines. There we go. All right, and our buses are gonna be that. We're gonna split this by commas. And we're gonna select anyone that doesn't equal a X. What am I doing? If it doesn't equal an X, parse it. Oh, what am I doing? Right. Otherwise, let's give it a 0. Cannot be applied if string and character. And then we're going to say where D does not equal 0. And we're going to put this in a list. Okay. Let's see how that looks. So our departure is 9:39 and our buses are wrong. So you should be looking at line 2 or index 1. All right, our buses, we have 5, 7, 13, 15, 9, 31, and 19. And just in case, let's sort these buses. So we need to find the factor of one of these numbers that's greater than 939. So let's see. For each of our buses, I guess if we can depart at exactly 939. Oh. If our departure modulus bus equals 0, then our bus and our wait time. Then bus equals depart bus. If okay, depart bus equals bus and remaining. Otherwise, we're going to create a dictionary. A dictionary of buses. So this is going to be, the bus is going to be the key. And the rest, and what am I going to call this? Selected buses? It doesn't make any sense, but oh well. Else, selected buses dot add bus remain, and we're going to return Yeah, let's just do this. I guess we could have turned that into link, but whatever. Return selected bus. Then min value. Wait, does that? That's not how that works, right? What do we need to return? Need to wait 5 minutes, multiplying the bus ID by the number of minutes. How do you do a min for selected buses? What does this want? The selector should be the value, right? What does this return? An integer? Why an integer? Ah boy, let's stop messing with link and just use a for loop. All right. If bus.value, which is the wait time, is less than wait time, let's make this 32 max. Then set the wait time equals bus.value, and the part bus equals bus.key. Return wait time times parted bus with string. I'm not sure if that makes sense. Let's see what it gives me. 7. We should have got 5 times 59. But instead we got a wait time of 1 and a depart bus of 7. Seven. $939 modulus 7 is 1. 39 modulus 7. Okay, I completely did this wrong. Our remainder Okay, that's not how we figured this out. So to figure out the time, I guess we need to multiply until we're greater than 939. Seems like a bad idea. What? Okay, fine. Let's see, well, time is less than departure. Then time is going to be multiplied by, we're going to add, no, not multiply, add. We're going to add the bus departure time. And then once we get here, it's going to be selected buses that add the bus, and this is going to be time minus departure. Okay. So this time we got it right. 295. It seems like a bad solution, but oh well. $41.35. I wonder if there's a more elegant way of solving that. But let's see. The shuttle company is running a contest, 1 gold coin for anyone that can find the earliest timestamp such that the first ID departs at the time and each subsequent listed bus ID departs at that subsequent minute. For example, suppose you have the same list. An X in the schedule means that there are no constraints on what bus IDs must depart at that time. This means that if you're looking at the earliest timestamp, 7 departs timestamp T, bus ID departs 1 minute after timestamp T. There are no requirements for the restriction on departure at 2 or 3 minutes after timestamp T. There are no constraints on what the bus ID must depart at that time. Oh, this is super confusing. The only bus departs that matter are the listed bus IDs at their specific offset from T. Those bus IDs must depart at other times in other bus IDs. So they're all 1 minute apart. In the above example, bus ID 7. Okay. The earliest timestamp that matches the list is 3417. So many bus IDs in your list. Surely the actual earliest timestamp will be larger than this giant number. Okay, so I'm guessing a brute force method is probably not the method. So how do we determine this? So first of all, we need to get rid of this. Well, I guess we can just what are we gonna call this? Let's just call it buses 2. So buses 2. Okay. So if it's an X, we're just going to give it a value of 0. So we need to find a factor of 7 that's 1 off from a factor of 13 that's... So we really only care if... What? This is 2 off. Bus ID 59 departs 4 minutes after timestamp T. There are no requirements. Oh, that's because there's an X between here. So we only care about 713 and 3119. We need to find... the 1 minute differences between these two and 1 minute differences between these. Does this matter if this departs? I guess this has to be at least 2 away to allow this to be in there. Or, I wonder if we can solve this with Z3. Let's get, where's that NQueens project I was working on? So Z3 is a SMT solver. So let's get Z3 into our project. Z3. Microsoft C3, okay. Are you gonna build? Yeah, apparently it'll still build. Okay, for this, we want to set up a Z3 model. So let's get a context going in. What do we need? Microsoft C3. Get ourselves a new context. And we're going to have how are we going to set up our rules? Okay, so we just need buses to into an expression array. Call this X. And it's going to be a length of buses 2, I guess. And what we're going to do we're going to say that these are integers that are, we don't need this. We're going to create a constant. We're also going to create a this is going to be a regular expression. Let's see. Val C is going to be now this will be a full expression. It's going to be something like this. We're going to say that each of these numbers, well, actually, int is not going to cover it. Long expression? Is that a thing? I'll just give it integer. I don't know if integer means if it's going to be constrained to int32. I don't remember there being another type of expression though. it's going to be at least less than 0, or greater than 0. I don't think we want to set an upper limit. What else do we want to do? All right. So for each one, we need to start creating some rules. Let's see, so if I does not equal buses 2 dot count minus 1 and buses 2 I plus 1 does not equal 0, then rule C equals it needs to be that it needs to be 1 greater or 1 less than the next one. So this is, not a great, problem solving solution, but I am kind of interested in seeing if I could solve this with C3. Actually, should I give up on this? I've already spent like 15 minutes on this. How else would I solve this if it wasn't for Z3? It needs to be I guess we can start by jumping through the first bus 7 at a time. And then we can say that if the next bus is let's just start walking through this. Let's put this away before I hurt myself. All right, so let's start with the first bus. What about our test input? That doesn't start with X, does it? No, it doesn't. I guess we need to count the number of zeros, or the number of zeros, which is x's, after 13. And it needs to be a minimum of, the number of x's. So I equals 0, 0. We'll leave this one blank. It'll be basically a permanent loop. plus equals the first bus. All right, so we'll jump through 7 at a time. And then, and then what? We're going to count the number of X's after the current bus that we're on. So that'll tell us how many numbers of, I don't know, whatever that we're at. So from there, we need to jump. So this needs to be a long for one. It's gonna be an integer, I guess. Let's see. So we need to start at I. Wait. If number X is equals 0, then I guess we do need to loop through each bus. We'll do this for each bus. We'll say we'll be at index B, and this is going to be at index B plus 1. So if the current buses has no X's after it, and I plus 1 modulus buses 2 plus 1? I plus 1 and modulus buses B2 equals 0, then we're good. If we're not, we need to skip. Which is just going to jump us to what, the next bus? No. So we start with the first bus. We count the number of zeros. And if we say that the next one is not valid, then we need to jump out of this entire for loop and keep on going. Otherwise, we need to loop through we need to check whether has to be at least one, at least past the number of x's. Right? So between 13 and 59, it had to have been at least 2. So 1, 2, we're 3 away. Right, 22 and 5. So we're at least the number of x's away. And we need to check one at a time, right? A modulus buses 2 b plus 1 . Now I've gotten pretty messed up here. I need to be looping through the first bus one at a time. Right? And I just need to be checking whether this value is valid. Yeah, I guess we're going to have to count the number of x's multiple times. This is going to be the number of x's for 0, or for index 1. In our test input, we did have zeros after the first one. And if we did, so we need, K needs to be a modulus of buses 1 plus num x's. No. No, that's, yeah, that's right. I guess this can be an integer. And I guess our limit is going to be A is less than buses 2, 0. K plus buses 2, 0. Or no, I plus buses 2, 0. Now we need to do the same for everyone after. I guess we'll start at 1, right? Buses 2, count. And we'll do this. We'll start at B plus 1. Count the number of x's. We'll do this found thing again. K equals I plus, this has gotten super complicated. So once we've gotten here, we are checking I plus number of x's less than or equal to this. This needs to be b. We don't start it. It's I plus b, right? This one, if it's not found, I don't think we want to continue. Oh, we need to do something like this too. All right, I starts at 7. Number of x's, we should get 0 here. One. Mm-hmm. All right, we got number of x's is 0 after the first one. No, why are you breaking? Plus is 2. Seven plus 1, 8. Needs to be... It's not break, it's continue. What about you down here? You do need to break. I feel like you're getting too far. You are. All right, let's step through this. So number of x's, 7. So we want this to be number of x's equals 0 and I plus 1 modulus 13, which should be this guy, right? Yeah. So we should eventually get to an I of this. So let's say if I equals this number, we want to break on that so we can see what's going on. All right, so we're at this number. We should see that this doesn't continue, right? But it does. Number of x's equals 0, and 10687 plus 1. Oh, you know what? This probably needs to be like this. What are you doing down here? Attempted to divide by 0. No, I didn't. What are we at? B. We're at 78. Is 79 modulus 13? Why did you pass on? No, you're at 77. So is 78 a dividend of 13? Yes, it is. Okay. So we're correctly at this place. We're at, we're at B1. So we're at 13, right? We should have counted a number of zeros of, why did you get 0? We're at 2. Buses 2 equals 0. Wait, what? Why did I add this? Should it be like this, right? We got to this number. We successfully passed that. So the next number is modulus of whatever. Let's see, what are we doing next? Oh, this should only be if number of x's is not equal to 0. But this guy down here, so if you're not I guess we can do this. Else if number of x's is not equal to 0. No, wait. I guess this was correct. Num x is not equal to 0. And do this thing. We start at what are we doing? We're counting the number of zeros after 13, so we should get 2 here, right? Okay, we got 2 number of x's. And then down here, we should be checking if this should be skipped. No, it doesn't get skipped. What am I doing? We only want to break if number of x's equals 0. Number of x's equals 0, and this is not a modulus of whatever, then we break. Let's check this again one more time. So it's number of x's equals 2. So we should just skip this, right? But down here, we get a divide by 0 error. So buses B plus 2. So position 3. Oh, should it be plus number of x's plus 1? $350. $350 is a factor of 7. $351 is that a factor of 13. And then $352, $353, $354, is that a factor of 59? Oh, $354. Then $355, $356, is that a factor of 31? $357, 8, 9. So what, 350 350 shouldn't have gotten past 357 because that's greater than I is 350. K, what K are we at? 354? Oh. No, we shouldn't be breaking. We need to check every one. So it should be that makes sense. No, it didn't work. Let's see. So this gets two x's, two number of x's. We're at what? B1. So 13. So we found one for oh. We shouldn't be checking 0. Yeah, we shouldn't be checking B2. All right, this is B2. We should stop at B4, right? This is 3, this is 4. So 4, we continue on. We count the number of x's after 59, which should be just 1. And we're going to check. We're checking. What are we checking right now? We should eventually get true for one of these. Right, we got true for what? $787 for 4 plus 1, 5, 6. For bus is 6. So 31 is a factor of 787. Correct. So we currently have bound equals true. We break, which takes us to the next one. We're at what? B5, so we should be going to B6. And B6 should be the last one we check. Maybe that's the problem. Whoops. Dang. Where were we? We should be stopping at one less than the last one. But we're not. Let's see, 2, 3, 4. What does 6 look like? So we go through 6. We have 0 x's. Ooh, why are you saying no? So B is 6. Six plus 1. So we're asking if 19 is a factor of 788. Oh, you say 0. Wait, you should say 0. Nineteen is a factor of 788. Oh, that was the same problem I had before. This needs to be in parentheses. Whoa, whoa, whoa. Okay. $34,000. This is a factor of 7. 40 is a factor of... Now we gotta go through some checks here. So, is this a factor of 13? Yes. 41, 2, 3, 59, 44. Yeah, this one shouldn't have passed the 59 check. But apparently it's saying it did. 88,000 seems to think. Let's go through the check again. 7, 13. Let's see, 40, 41, 42, 33. We have an off by 1 error here somewhere. Let's see, what is this number? 38. Let's see, where do you think you are correct? Checking, we want to check what? 44. Okay, this is where we should have a failure. Or no, we should have failed at 13. Let's go through this again. Dang. One more time. All right, we're checking 1. Number of x's is 1. Oh, number of x's is 2. So we skip this check and we go through here. So 43 plus 1 plus 2. $38, $39, $40, $41. Should be 42. Uh, 479,000. That's another one to check. Modulus 7. Modulus 13. What's this? 3, 4, 5, 6. Modulus 59. 57. 8. What is that? 6 difference. And then 9. 200. We have another off by 1. Why do we have it off by 1? So we were wrong when we got to 59, I think. 4. So we should get number of x's of 1. We should be skipping this. And we're checking if 198. Why are you 198? You should be 200. Oh, we need to increment something here. It should be like all the number of x's I plus b plus all of the x's before. Can I do this? No, I can't. (92 plus 4) plus number of x is 1. 97, but or I guess technically 98 because we had that plus 1. But that's not right. What it really should be is 100. We need to count the number of x's not from b, but from I. We're at position 4. We should go from 1 and then so we should count 2. If we're at this one, we should count 3. Let's see how that works. No, that's not right. What did we end up with? 0. B1 should have counted 2. I guess just start at 1 and always count from there, right? Yeah, why didn't you get 2? Oh. I guess. Count until you get to... Dang. I guess the number of x's up to... Number of x's is 2. $354. You're saying 354 is a factor of 13? No, 354, you're saying it's a factor of 59. Which is correct. And then what? We're checking... Number of x's... What do we get? It's 3, right? Between 13 and 31. So we're saying 358. Okay. I guess here we should have changed found to false if let's see, I plus b plus numx is plus 1 is less than I plus buses to 0. I guess we can do this. Hmm. Oops. So found currently equals true. On what condition do we get a false? When I plus 785 plus 3 785 7 plus 3. I see. Hmm. Really, we need to be counting k. I guess just set it back to false. And only set it to true if we get here. All right, and what condition do we get set to false? 3, 4, 872. Dang. Saying B4 is not correct. Is that what you're telling me? Two, 4. Okay, so we get number of x's equals 3. Oh. No, that's good. So we're going to set this to false. 3 plus b. I guess that's... Why were we doing that? I think that's what we need to do. No, that's not right. Why did we need to count the previous x's? It should be k equals I plus b plus number of x's plus 1. Go until we hit 7. And then I think this part might not be right. We want to check yeah, why wouldn't this be right? Oops. Whoops. Here we go. So what did we say about this number? that 59 was wrong. Or no, 31 was wrong. Three, 4. So here we should get a false. So we got 1, previous x, 1x. So we're going to start at 198. But we should be starting at 200. Okay, we're back at not working. It's saying that B4 is not right. So once you get to 59, you should be checking. We should be checking if 787 is equal to 31, or a modulus of 31. So what did we get for that? So it was 781, 785, 786, 787, 788. Why did you go to 788? Between these two, that give me problems. So it's checking 198. So we start at 2, 7's good, 13's good, and this is 4. 2 plus 4 is 6. 5. Oh, you know what? It's because for this one, we skipped a few. So what did we do? We went... Ooh, that's bright. We went 192, which is bus 7. 193, which is bus 13. 194, we skipped. 195, we skipped. 196, we skipped. 197, we skipped. And then we got to 198, and that was 59. And then 299. Yeah, we shouldn't have. Instead of checking 199, or we should have skipped 199 and then checked 200 for 13, and that would have been incorrect. But instead, we checked something. What did we do? We checked yeah, we checked 198 again for 13. So we should have a counter if we have extra skips like that. So it's not about the previous x's, it's about our extra skips. So I guess we need to save this here. Call this extra skips. And if we don't find it, we're going to say extra skips. And this is going to be number of x's plus extra skips. Attempt to divide by 0. So what are we at? We added extra skips here. Oh, I guess not for you. Ooh, we got it. That's our number. All right, so let's get our test input back, our actual input. And what we need to do is return, what is the earliest timestamp such that all of the listed bus IDs? So what was this? The earliest timestamp? $788. Let's, I guess, try these. The earliest timestamp, 3417. You're saying you didn't find it. What are we? 3417. All right. Why did you say you didn't find it? So let's do the math here. $34.17 modulus 17. We skip 18, go to 19, and check modulus 13. Then we modulus 19. What? Oh. So we're filling the first checks somehow. So what do we get? We have 1x. Oh, that was our problem. This is what we did down here. So it should be if number of x's equals 0 and this is not true, then we should continue. Oh, 187. Why do you think 187 is right? Yeah, we're back at it. We almost got there. But it's something wrong with this first evaluation. So what did we do here that fixed it below? Number of x's does not equal 0. We already have found equals false. I guess we need to set this as found equals false each time, right? No, we don't. One plus number of x's. Right, so for this one, that would be position 2. K equals I plus number of x's. I plus number of x's plus 1. $87. All right, let's check 187. 187 modulus 17. 188, 189, 13, 90. So this, I guess we can do this up to 17 times, right? 4, 5. All right, and then 6 could be 19, but it's not. So we should be having our extra skips being counted up here too. $187. $187 should fail when it gets to 19. B1, which is 0. 2. 2 is where it should fail, right? Yeah. Because it should check 19. Whoa. Number of x's equals 0. Oh. Found equals true. Hmm. What did we check? 187 plus 189. 190. Oh, I guess we need to check the extra skips here as well. That one still works. This one is not working. And it's all because of this first check. So we get to B and wait. Oh, we gotta do the math on this one too. So what is I at? 204. So 204 modulus 17. 206 modulus 13. So 6, 7, 8. So we have 2 extra skips. So the next thing after 13 should be 19. Oh. 204 looks correct. (17x 13.9). Why is 204 not correct? You got that one right. This one's right. What the heck is wrong with this one? Why 204? That one's not right. Maybe I missed a rule somewhere? Bus ID 7 departs at timestamp. This is fine. The only requirement on the minute is that bus ID 19 departs then. So that would be this check. I guess it's less than or equal to. That makes this one wrong. But why is it wrong? Nine, 10, 11. This is way over 7. Why? Hmm. Well, let's continue to debug. Why are you working? So you should fail at 2. So we have no extra skips. Wait, what? B1. Oh, you should fail at 1. So 2 number x's, or 2 x's. And this one should fail when it gets to Ooh, what are you doing here? $191. Wait, what? Whatever happened to that number I was checking? 187. Oh, what the heck was I doing up here? I was doing this wrong. 189, 190, 191. And then 2, 3, 31. So this number looks correct as well. I am baffled why that's not a correct answer. Bus 13 departs 1 minute after. There are no requirements or restrictions on departures at 2 or 3 minutes after T. Oh, 2 or 3. Oh, holy cow, how do I do that? X in the schedule means there's no constraints on what the bus ID must... It says no constraints. So why are you saying 2 or 3? There are no departures or restrictions at 2 or 3 minutes after timestamp T. There are no requirements or restrictions on departure at 5 minutes after. Oh. No, wait. Timestamp. Two or 3 minutes? So it's saying that I can't keep counting? Is that the trick? So I should be stopping at... What should I be stopping at? I guess I should be only checking. I should only be checking this guy. See, wasted a lot of time for not reading the question. So this guy should be doing the same thing if this modulus this guy. All right, let's check this guy down here again. Yeah, there we go. So let's clean this up a bit. What a mess. All right, I think I got this. Let's check a few more. I shouldn't be saying that. That one's right. Two 10. $86. Okay. So let's get our test inputs. Let's run this. Oh, it's not finishing fast. So what am I doing here that I can speed up? So I don't need number of skips, right? Or do I? I do need number of x's. I don't need extra skips. Hmm. Guess I could take this one, see if I can speed this one up. 10 milliseconds. How can I make that 0 milliseconds? So we're jumping through each factor of the first number. Then we go to the second number. We check if the next number is a factor of that guy. I guess we could memoize this number of x's count. So contains key 0, number of x's equals xmemo 0. Else we do this. And then we say, if you want to add, zero, and then num x's. All right. And then we do the same thing down here. If contains key b, number of x's equals b. Otherwise, xmemo add b num x's. How much this makes it slower? Are you kidding me? Is a contains key lookup that slow? Whatever. All right. Well, I guess for this, I mean, you don't have to count the number of x's, because this pretty much checks if the next one equals 0, and if it does, it just skips it. What's this number they gave us? How many zeros is that? 15? That's a max long value for C sharp. Okay, so it should be within our length value. Maybe we should start from the top and go down? Oh, well, I guess we can't do that because then it's not the first timestamp. Duh. Hmm. I guess while I'm thinking about this, maybe I should have this running. What? What can we do here? How do we reduce the search space? We're checking every 41. Hmm. How do we do a parallel 4? There's not a... I don't want to increment by 1 every time. increment by more than one. I guess this. Ooh, I don't want to do that. What is this? Parallel for each? Ooh, copy and paste from Stack Overflow. Don't mind if I do. What are we doing? A parallel for each. Better enumerable. Not step range. Start from it buses to 0. Go to I don't know. N32 max? No. N64 max. And step by yeah, I get that. What are you complaining about? No, in a long enumerable enumerator. Okay. Again, I get that. I'm gonna go ahead and stop you. Tired of seeing these errors. So let's move you. How do I break out of a parallel for each? I want to say parallel dot, wait, state. This one takes a long time. Five milliseconds. Compared to that 10 we were getting before, probably the overhead of starting each of these threads is probably not worth putting this into a for each loop. I am maxing out my CPU at least. So I'm properly using the CPU to its maximum usage. But it's still not the best way to solve this. Yeah, there's got to be some better way to do this. Oh, well, it does give me a hint right here. Is that all I have to do? Start at this number? Maybe not. Well, I guess it at least did speed it up a bit. How would you know it's at least this? Not like I can do a binary search or anything, because I need to check from the bottom up. Ooh, is my computer doing okay? This is probably some math thing. Is there a faster way to do than using a modulus? Let's get rid of this for each. Ooh. Let's get rid of this guy, yeah. Let's start at this number. Let's do a quick sanity check first. Oh. This is what? This is using, what, a single core? So it's not exactly... Dang, I should have kept that for each. It's okay. Let's look at the previous examples. 17... Is there some... I feel like this is giving me a hint here. Hmm. I guess what we can do is find the first common factor on our numbers. But it's not a common factor though. It's a common factor at that. Yeah, it's not a common factor. Yeah, for all I know, this can take like uh, forever to run. Ooh, I wonder if this is actually taking forever. No, maybe not. Lowest common multiple. Hmm. Let's see, where are we spending the majority of our time? We're spending the majority of our time. Get item. It's not very useful. What do you mean top function? Yeah, it doesn't help at all. Majority of my wait time is in IO. Because maybe this one does need the memoize function. I mean, you are asking for X quite a lot of time. So let's add that back in here. Oh. We seem to be spending the majority of our time right here in this check, which is checking whether this one and our very next one just checking whether 41 and 37 both are valid. I guess we're already checking 41 by just adding by 41 every time. Is that something we can speed up? Hmm. The denominator is known at compile time. Do we know the denominator at compile time? M is power of 2. What we have here is definitely not a power of 2. We're not going to know what I is, or will we? How many number of x's is this? It's 34. So what would that be? 41 plus, dang, what did I say it was? 34. Plus 1 is 76. Well, I should have known that was not a power of 2. I'm not sure if figuring out magic solutions for modulus is correct either. Uh-oh, what am I in? 3 hours in already? I guess I don't particularly mind. It probably doesn't make for a very good video, you know, being so far into this. I'll probably keep working on this, but I think I'll cut off my video. Or will I? I'll think about it. Hmm. You want to check if hmm. Is there another way to think about this? I'm sure there is. Here's my... This might be the hint right here. So this one shows that if we throw in the x, the fact that we're changing the timestamp a bit makes this pretty confusing. I guess we can pre-calculate the x's first. Still getting the right answer. We're getting 14 milliseconds though. How can we get that time down? What are we saying here? Number of x's equals 0. Do this. Else. I guess we don't need to do this double calculation twice. We just need to do that. Am I still getting the correct answer? Yes. Oops, messed something up. It hasn't increased the time at all. It's a little easier to read, I guess. Hmm. Is this any faster as an array? No. Let's see. We are not getting any improvements here. How do we figure where we need to start? Hmm. We just need to check. We gotta check every modulus. So we gotta do up to 4 modulus calculations for this one. And I guess for every other one. How do we prevent from doing so many? You should be breaking too, right? No. You just need to continue on to the next one. I guess we can go through our X memo. No, I guess not. Set. No, that's dumb. What I guess what we can do is okay. I guess I can do that. Oh. Doesn't help the time at all. Maybe I can count. Maybe I can count the other buses at the same time. How would that work? So how many numbers do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 each. So we have an X memo of 9 each. how does this increase? Hmm. Let's do this with this simpler one. So it's just, let's add the last one too. 0, 2, and 3. $34, 17. Okay, so what do we want to do? We want to we're going to say bus dot value plus equals right? Hmm. Hmm. No, this probably won't work. See if I plus how about we do this instead? Where we have a list of the bus index. Hmm. Wait, why am I checking this? Okay. I guess I should kill this stream. Yeah, I think this has ran long enough. I'll keep working on it, but I don't want to have like a 10-hour video.